This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Chris.
And in our bi-weekly episodes, we'll discuss the good, the great, and the ugly of AI. If you're craving even more, check out our 15-minute Banana Bites discussions on Data IQ's LinkedIn and Twitter every Wednesday at 2 p.m. EST. On today's episode, Chris and I are hitting the debate stage to discuss some of the more controversial issues in data science. Hey, Chris.
Hey, Triveni.
I was thinking today we could be a little funny and maybe play a little devil's advocate. What do you think?
Oh, gosh. Okay. I'm interested to hear what this is, but I'm also a little bit nervous.
Good. That's usually how people approach me in general. And so what I want to do is chat about some of these like major dividing lines in the world of AI and ML. Things like, oh, do you do 4 spaces for your indent or a tab for your indent on your code?
Oh my God, the issues that really matter.
The issues that really matter in this day and age, right. And I was thinking we can sort of take turns playing up the side that we wouldn't normally go for. I don't think either of us are very hard line on anything in AI and ML, except for don't use it for bad purposes. But, in general, it might be interesting to kind of tease out the debates and see what are all the little different nuances and reasons why we might want one thing over another.
Yeah, I really like that idea. I know that we generally tend to see the positives and negatives in everything, right? But if we try to argue one point very heavily, then maybe that'll give us a deeper appreciation for it. So I'm all for it.
All right, let's do it. So the first thing I want to talk about is a little spicy. You know how I like to keep it interesting. And I've heard in a lot of different places that data science, machine learning are nothing more than fancy statistics. At the end of the day, you're doing a random forest or a regression underneath all of that other fancy modeling and mechanisms. So I'll let you pick what side you want to take. Data science is just fancy statistics, yay or nay?
Wow. Having an appreciation for both data science and statistics, I really do think that they're related, but they're different. So I'd hesitate to say that data science is glorified statistics. I just kind of think that there's a little bit of a partition between the two.
Okay, interesting. I like that you've taken that tack because I know that statistics are very near and dear to your heart.
Yes.
And so I'm not surprised to hear you say that. No, they're very different. I mean, they're similar, but they're different. So what do you think differentiates them?
Yeah, that's a good question. So I think statistics, when I boil it down to its basics, it's what do you do in the face of uncertainty? Or like, how do you make sense of uncertainty? That's what, to me, statistics is all about. So oftentimes you hear, about probabilities or hypothesis testing, or we're talking about generalizing our findings to a larger population and so on and so forth. That is what statistics really is at its core to me. On the other hand, I think data science is more about a broader sense of what to do in terms of strategy or taking the science of data science. It tends for me to think about experiments, like classical scientists in a lab doing, mixing together things from beakers. But that's what a data scientist does too, just with data and numbers. So there's certainly things that relate from statistics to data science, but I think they're very different entities.
I think I get what you're saying, especially because statistics seems to be oriented, traditional statistics in the social sciences or even hard sciences is really about testing for either a difference or not in some sort of outcome, and then trying to associate that difference to a correlation and not a causation. What doesn't strike me as super different with data science and statistics is that at the end of the day, we're using some set of data to draw observations and conclusions about the world. And yeah, in statistics, traditionally, you're trying to understand whether or not there's certain correlations happening between your observed outcome and your inputs. And with data science, machine learning, you don't really care about that correlation. All you care about is that, am I getting what I want out the other end? But I do think that that simplification of data science is actually an oversimplification because yes, a lot of our machine learning and all of that is oriented towards predicting some sort of outcome. But a lot of what we do as data scientists is actually providing basic information, basic statistics, even like baseline graphing and visualizations so that we can understand the data or the situation that we're working in. Mm-hmm. And that's where I think that like the statistical background that so many data scientists bring to bear is actually really relevant. And as a result, those two things aren't as different as we might make them out to be.
Those are fair points. I do think that maybe the questions that you ask in statistics, or like the classical sense of statistics, maybe a little bit more, my heart's going to bleed by saying this, maybe are a little bit more basic than what you're asking in data science. So for example, like you said, in statistics, you're usually saying, is there a difference in means? Is there a dependency among these variables or an association among these variables? Whereas in data science, you're usually talking more about, okay, how do I ask a lot of these questions to inform how am I going to optimize this system, or how am I going to improve this system, or what do I do if I have a lot of constraints? So the statistics, I think, will help answer a lot of questions that will inform the strategy that you'll use in data science.
Yeah, no, I see what you're saying, that like data science is asking a different set of questions and then using certain statistical methods to say yes or no, we're able to get this kind of answer or this kind of model built. But in statistics, again, it comes down to the question just being of a different nature. Okay, you've kind of convinced me that they're different. I still think that a lot of what we do in data science is not any different than what people were doing with statistics and causal modeling and forecasting from way back, 10, 15, 20 years ago.
It's just a rebranding.
See, you do agree with me, actually. Did I convince you or did you convince me?
I don't know.
Okay. So clearly this is still up for debate, but it's definitely something that's top of mind for a lot of people.
So another topic that I think comes up quite a bit, whether you're in industry or academia, is about the coding language that a lot of data scientists or statisticians end up using. And this is a fiery debate that I think has been around for a while. And again, we're going to try to play this game of R versus Python. So you gave me the opportunity to choose my stance, quote unquote, for the last conversation here. But Triveni, what would you prefer? Which language is better for data science? Is it R or Python?
Oh my God, that's such a mean question. Okay. In all reality, it depends. Mm-hmm. But since we're forcing a debate, I will take the R stance. So fun stuff. I actually got into data science because of R. During the coursework of my dissertation, I realized that I wanted to have some pretty graphs for the final product. So I went out and taught myself some R, some good old ggplot, and got these pretty viz. And then from that transitioned into other data science topics and then ended up learning Python. But I still have a soft spot for that R in my heart. And I think the reason why folks would be very heavily in the R camp is that it was a tool written by statisticians. And so underlying all of the algorithms, all of the functions, all of that are really core, solid statistic foundations, right? Which, as we just discussed, statistics are a key underpinning of any good data science practice. Mm-hmm. And so I think R in that sense gives you a lot more power, especially around things like basic OLS, forecasting, any of the other like good things out there. And, there's been a lot of development writing out more of the traditional machine learning algorithms into R, things like the carrot package. And, then there's the tidyverse of all the different packages for cleaning and wrangling data.
Shout out to Hadley Wickham.
Shout out Hadley Wickham, who I have met once. I don't know if he doesn't remember.
Did you get his autograph?
No, I actually asked him why he doesn't work with data table. And he kind of was like, okay, nice to meet you. So,
Icebreakers for data scientists.
Icebreakers for data scientists. Why don't you work with data table? Which actually now Tidyverse does use data table underlying. So there you go. I think the point is that there is a lot of growth and development in the R space. So maybe some of that hate isn't always deserved, especially when you're looking at it by an industry level. The healthcare industry, biometrics, all of that good stuff, they rely heavily on R for their work.
Yeah. So, you are tapping into the depths of my soul here because, as an avid R user for over a decade, all my past students are going to be telling me right now, you're flipping the switch here and playing devil's advocate. So I'm going to have to argue for Python here. You know what? Python is a really fantastic language too. And it's a general purpose object-oriented programming language that has a lot of functionality, from web development to software engineering and data science. So I'd argue that Python is actually a lot more flexible because it wasn't written by statisticians. So it's a general purpose computer science language. And I think one of the biggest benefits of Python is that it's easily readable and understandable. And if you're just breaking into coding, it's a fantastic first language to pick up and start running with. And I think one of the criticisms of R is that the syntax can be pretty confusing. There's a very heavy learning curve. And yes, granted, it is true that R is definitely was built for statistics and has a really, really great statistical graphics and visualization capabilities. You can do that in Python too, maybe not as well, but the functionality still exists. And then one big thing, I'd love to hear your response to this. Python is really on the cutting edge of deep learning.
Well, all those same things are coming to light in R too, right? It's not like R is a dead language that no one is focused on. I think there are still quite a few different places where it's being used actively, like Airbnb even has a quite hefty R shop. A lot of big healthcare startups are R shops. And so, yeah, Python is maybe a little bit ahead on the curve when it comes to using deep learning architectures, but R is catching up. I do think you have a very valid point about Python written by people who are actually trying to program and create like a general programming language. R, was invented by statisticians. So it does a really good job at what it does, but there are shortcomings, especially when it comes with like trying to interact with other external aspects of data science, whether it's plotting out onto the web or creating API nodes. And now it's time for that part of the episode where we take complex data science topics and describe them in plain English. So Chris, can you describe for me correlation versus causation in plain English?
Sure. So correlation versus causation is something you'll hear a lot within statistics and data science. And it means that when two variables or two activities in the world or two actions are associated with one another, that does not necessarily mean that one causes the other. So let me give you an example. Say that you heard somebody claim that if you fall asleep with your shoes on, you're more likely to wake up in the morning and have a headache. And maybe those two actions or outcomes are very much associated with one another, but that does not mean that falling asleep with your shoes on causes you to have a headache. And why might that be? Well, one reason could be that there is what is called a lurking variable, something else that's going on that's related with those two activities. And maybe this person who fell asleep with their shoes on had a very late night of partying and drinking a lot. And maybe that's really what's causing them to have a headache in the morning and also causing them to kind of forget to take off their shoes before going to bed. So in this case, the correlation did not imply the causation.
Thanks for explaining that in English.
So yes, there certainly are shortcomings of both languages, I think. But something that I think is a bit of a gray area that I hear a lot is that there's so many libraries in R. And there's, 10 different ways to do the same thing. Whereas I think typically in Python, there's a lot of creativity to be had in writing code in general. But there's usually one optimal way, one better way of doing things in Python that may, standardize things, but maybe lacks creativity. What do you think about that?
Yeah, I hear you, right? There are a number of R libraries, and there's a lot of good R libraries out there that you want to use, but then it turns out that it hasn't been updated in like 3 years and it doesn't work with the newest version or whatever it might be. So yeah, I definitely hear that. But within Python too, like there are multiple ways to accomplish a task, right? Like even Pandas data frame, right? You can choose to delete something by its access number, or you can choose to delete it by like an actual variable name. There's all sorts of different aggregations and group bys and different ways to cut at this data that isn't necessarily standard in any one way. And I think the best example of this for me is that if I'm looking for some help on a problem, so I Google it, go to Stack Overflow, there are like usually 3 or 4 responses to what I want to do. And someone will have, oh, you could do it this way. I wrote a function like this. Oh, you could do it this way. You can use an inbuilt function like this. There is always the quote unquote Pythonic way, which is the like most optimally written computer science beautifulness.
The one-liners.
The one-liners, right? Exactly. But you and I both are not Python programming experts as our baseline. And so for us, like that one-liner is not something we're ever going to come up with. And so I think that like to say that there's too many libraries in R and that's a shortcoming, yes, agreed. But that doesn't necessarily make Python a very standardized where everybody knows the right answer right away, because it is a programming language. So you either need to be a programmer or be willing to write some hacky code. And actually, that reminds me of my last question for our debate here. And it really revolves around that Stack Overflow Google stuff. A lot of people will claim these days that no one writes their own code anymore. Everything is just a Stack Overflow, copy paste, cut it together in a special way. So for an aspiring data scientist or anyone in the field, do you really need to be a coder, right? Do you even need to know how to code? Or can you just get away with Googling? I guess I'll let you pick your side on that.
Oh, wow. So I guess this boils down to, do you need to be a great coder to be a great data scientist? I'm going to say no. I see all the positives in learning how to code and stuff like that, but I think there are so many other skills that make a great data scientist that being the best coder on the face of the earth is a good thing, but I don't think it's necessary to be a great data scientist.
I hear you. I do think that on the other hand, you can make an argument that for the more advanced machine learning algorithms, the more advanced developments, the really cutting edge stuff, you need to be a good coder. If you're trying to develop a brand new model out of the box, you can't Stack Overflow for like, how do I write this model? Because you're trying to do it for the first time. So you have to be the pioneer who writes that code that you can share back with other people, who then is the person writing out stuff on Stack Overflow to give other people guidance. So I do think that you can make the argument for being a great coder is necessary to be a machine learning data scientist or an algorithm writing data scientist, but it's not sufficient to be just a great coder. Because, that's where the like statistics, all of that good stuff comes back in. Computer programmers are good at programming algorithms, but they're not good statisticians. They're not. And so being a data scientist, a great data scientist, does require some more of that. I think now I'm just kind of agreeing with you. It's hard to argue that, oh, you need to be an amazing coder and that's all you need. You can be a pretty mediocre coder. And there's actually a saying, a data scientist is a statistician who knows how to code and a programmer who knows some stats.
I love that, actually. Yeah, because I think in this space, the variety is the spice of life, especially in data science, because everybody has a different perspective. Everybody has a different background. There are some data scientists out there who are the best coders on the face of the earth. They can write functions and objects and their own algorithms faster than I could ever write a single line of code. And that is a immensely wonderful skill to have in the space. But I don't think that's why they're great data scientists. I think that's one contributory factor towards it. I can think about myself. I would not brand myself personally as the best coder on the face of the earth. Can I write in a few languages? Absolutely. Can I get the job done? Certainly. But there's also other skills, the strategic skills, the critical thinking skills, the how to scope a project, how to manage a project, how to pick which algorithm may be best or tweak it in certain ways. I think there's an endless list of skills that define like an agility that a data scientist should have, because every problem you're going to encounter is slightly different than the other problems you've seen. And I think that is kind of the marker of a great data scientist. And coding is an important part, but it's just a part of that.
Yeah. And it's interesting because you can tell what a job or a company values in their data scientists based on what they ask you to show them, right? And so if you apply to a place and they say, well, let's see you write out this algorithm for us from scratch, or go ahead and solve this complex programming problem. Okay, this is probably a program heavy job, and you're probably going to ask me to write some of my own algorithms or contribute to some sort of code base. But if the questions are along the lines of, here's a case study, we have this kind of data, and we want to get this kind of information out of it. Okay, now I know that you're asking for a different kind of data science skill set. And so I think it goes back to a bigger question too of defining a data scientist. Maybe to be a great data scientist who happens to be like an algorithm machine, yeah, you should probably know how to be a great coder. But to be a data scientist who's really good at Viz, you might not need to know really good code because, A lot of the stuff can be done with existing tools, or you could be a really good coder so that you can use some good D3 and Node.js and all that other fun stuff. It actually just really depends on what you're trying to accomplish. You could be writing in Julia for all I care. Julia's a new thing, right?
Who's she?
Who's she? Exactly. I don't care, but can you tell me something interesting? Can you give me something useful to do with this data? Those are the questions that I think matter more. And these little debates are really just a distraction.
Yeah, 100% agreed. It's about the bottom line. What does this mean? How do we use it? We talk about that all the time. So not only is it about the communication aspect, I think there's a lot to be said as well for the collaboration aspect. And, there's a million different things you could learn within statistics, data science, machine learning, algorithms, blah, 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 programming languages. But you have to know what you have in your toolbox and maybe what other tools are out there that other people may have in their toolboxes. There's a plethora of things that you could do with your own tools. Collaborative efforts, I think, will help within this space as well.
Before we head out, it's time for the AI pioneers of our episode. And today I want to shout out the women who started the R Ladies meetup group. It was actually started in 2012 by Gabrielle de Quiros, and she found this group as a way for women working in the space with R to join forces and talk about different practices and different methodologies. Over time, this group has grown, and they are now a global organization with chapters all over the world, from Taipei to London and beyond. And in case you are interested in learning more about R, or you even want to just get involved with a group of really kick-ass women, be sure to check them out.
That's all we've got today in the world of banana data. We'll be back with another podcast in 2 weeks. But subscribe to the Banana Data newsletter to read these articles and more like them. And we've got links for all the articles we discussed today in the show notes below. Until next time.